Okay, so let's talk about sig figs and logs. Because there are a couple of questions in the sapling homework that we've discovered that will be specific about sig figs in these problems. Okay, so if I take the log of a number, the number of sig figs in that number becomes the decimal places in my answer. Okay, so that we're kind of blending the addition and subtraction rule and the multiplication division rule. Okay, so let's say I take the log, and let's use one of our previous questions. Let's say if I take the log of 4.3 times 10 to the minus 7. Okay, if I'm taking the log of a number, there's 2 sig figs there. So that means that my answer should have 2 decimal places. Okay, and when we did that, we found that the answer came out to be 6.36, 2 decimal places. Let's see, where's another example? So if I take the log of 5 times 10 to the minus 4, there's 1 sig fig there, so then I should have 1 decimal in my answer. And we would find that that is in fact 3.3. Right? 1 decimal place. Okay. Now it gets a little bit, it's tricky, I know, and I don't expect you to really have this under your belt as well as you do the addition, subtraction, multiplication, division rules. But I want to make you aware of this so that when you go to do the sapling and you're sure that you're correct and it's still telling you wrong, it's probably a sig fig problem. Okay. So before we leave this, let's talk about going the other way. Right? So if I take, if I go the other direction and I say 10 to the power of negative 10.7, I'm going the other way. So I'm going to start by looking at the decimal place. So there's 1 decimal. Ends up equaling 2 times 10 to the minus 11. So 1 sig fig. And let's find another example that's maybe a little bit more elaborate. So if I take and say 10 to the negative 7.64, I have 2 decimals right there, 2 decimals. So I'm going to have, in my answer, I'm going to have 2 sig figs. And that one turns out to be 2.3 times 10 to the minus 8. Okay, 2 sig figs. Right? So they are tricky, no doubt. But like I said, if you are sure that you're correct in how you've worked a problem and it's still telling you you're wrong, this is probably why. Okay? So I hope everybody watches this video and sees that issue. Why are you... Okay. All right, we completed our table. So let's do a little more practice. So a solution has a hydroxide concentration of 2.5 times 10 to the minus 8. Is the solution acidic, basic, or neutral? So we're talking about the OH minus concentration. (2.5 times 10 to the minus 8). Okay, so can we tell? Yes, we can. We can actually do this without any calculations, right? So at neutral, that's pH of 7. Okay. Acidic is pH less than 7. and basic is pH greater than 7. Okay, so at pH 7, my H plus is 1 times 10 to the minus 7. And my OH minus is also 1 times 10 to the minus 7. Okay, so whichever one is bigger wins, right? So if my H plus is bigger than my OH minus, then it's acidic. And if my OH minus is bigger than 1 times 10 to the minus 7, it's basic. Okay, so let's take a look at our 2.5 times 10 to the minus 8. Okay, this is smaller than 1 times 10 to the minus 7. Okay, if the OH minus is smaller, that means that the H plus has to be bigger, and that makes it acidic. Okay, so it's all about balance. So whichever one is bigger than 1 times 10 to the minus 7, that one wins. So if my OH minus is less than 10 to the minus 7, then that means the H plus has to be more, and that makes it acidic. Okay, what is the pH of an aqueous solution where the H plus is 0.001? pH is the negative log of the H plus. So if I know the H plus, then this is an easy problem. Now that we know the pH, ask yourself, is this acidic, basic, or neutral? Remember, pH of less than 7 is acidic. Okay. Solution has a pH of 12.2. What is the H plus in this solution? So 12.2 is bigger than 7, so this is a basic solution. Okay. So if it's basic, then we would expect our answer to be less than 10 to the minus 7. All right, so right away, we can count out some answers. So it's going to be in the minus exponent realm. So right away, we can count this one out, this one out, this one out, this one out. And 6.3 times 10 to the minus 3 is a smaller number than 10 to the minus 7, right? But we can also calculate it, so let's do that. So in order to find the H plus is 10 to the negative pH. So I can say 10 to the negative 12.20. 2 decimal places means that I should have 2 sig figs in my answer. And we're going to find that it equals 6.3 times 10 to the minus 13. Right? 2 decimal places gives us 2 sig figs. pOH of 5. The solution is acidic, basic, or neutral. We want to know what is the pH. Right? And the pH, we can find that from subtracting from 14. Right? 14 minus 5 gives us a pH of 9. Right? So if the pH is greater than 7, it's basic. Right? And if you're ever having trouble remembering less than 7 is acidic, greater than 7 is basic, just remember a simple fact is that the pH of your stomach contents, so a lot of you are interested in medical practices, nursing and the like. So the pH of your stomach contents is somewhere typically around 2. And what's in your stomach? Acid, mostly hydrochloric acid to be specific. So that's how I always help to remember for myself, is that stomach acids are a pH of 2. So that means that anything less than 7 is acidic. All right, what is the pOH of a solution having a hydrogen ion concentration of 0.15? So in order to find the pOH, I need to know the pH, right? And I have the hydrogen ion concentration here. So pH is negative log of 0.0150. That's my H plus concentration. And to be honest, I forgot to calculate this one. So we're just going to talk about how we find the pOH is 14 minus the pH. All right, so we'll take a look at our next slide and we'll see that worked out. So the negative log of 0.0150, we have 3 sig figs here, so we should get 3 decimal places here. And then 14 minus the pH gives us 12.16. Okay. Solution has a pOH of 2.5. What is the pH? So pH equals 14 minus the pOH. In this case, 14 minus 2.5, which makes 11.5. A 0.1 molar salicylic acid solution has a pH of 2. What is the concentration of hydronium ions in the solution? Now, this particular problem is giving you information you don't need. Okay, so this is a tricky bit. This stuff about 0.1 molar salicylic acid, you don't need it. Okay, all you need in order to find hydronium ions is the pH. Okay, so remember H plus, stop doing that, is 10 to the negative pH. 10 to the negative 2.0. Or 1 times 10 to the minus 2, which is that. Okay. So it'll be really tempting to use this information here. Okay? But if you need hydronium ions, all you have to do is go straight to the pH. Right. Basic solutions. So remember, if it's basic, my OH minus concentration is going to be a bigger number than my H plus. Right? So our first one, if it's basic, my pH will be greater than pOH. Remember, if neutral is 7 and basic is greater than 7, right? So if it's greater than 7, if it's the pH is higher than the pOH, right? Because remember, everything balances. The pH and the pOH balance just like the H plus and the OH minus. And then what about our second answer B? Right? They have an H plus less than the OH. And that will be the case also. 7, pH 7 is neutral. Both A and B are true. That's correct. And all of the above are true, and that's not correct. right? So in reality, the answer is going to be D. Both A and B are true. Which solution has the highest hydroxide concentration? Right? So right away we can eliminate some answers of the ones that don't even have hydroxide. Right? And remember from your previous chapter, how do we calculate ion concentration? So A has 1 hydroxide. So I've got a concentration of hydroxide of 0.1. D there has 2 hydroxides. So I'm going to have 2 molar. Right? Because there's 2 hydroxides in that molecule. All right, closing in on the end here. So now we're going to get into what is going to look like something foreign, but it's actually something you've already done.